Hello guys, this is Prime Concept. I will have our first example to handle under electric potential energy. Let's interpret the problem. We have 2 point charges are located on the x-axis. Q1 is this at 0. So telling you that Q1 is located at the origin. So our diagram would look like this. So this is x equals 0 and this is where we have Q1, which has a value of negative 2 microcoulomb. Now, and Q2, the same value at a distance of 3 meters. So we draw, so this is x equals 3 meters, right? And this is where we have our Q2, 2 microcoulomb. Now, the first question, we have two questions here. The first part said, find the work that must be done by an external force to bring a third charge, Q3, 2 microcoulomb, from infinity to x equals 6 meters. From infinity to x equals 6 meters. So let's say this is our x equals 6 and this is Q3. Same value, 2 microcoulomb, positive. Take note of the signs, they are very important. Q3 is positive 2 microcoulomb. Now, so we have the first question. The second part said find the total potential energy of the system of 3 charges. So let's start with the first one. Find the work that must be done by an external force to bring a third charge from infinity. Now, I mentioned that work done in an electric field, work done between 2 points, is given as change in potential energy. Work done between 2 points is change in potential energy. Now, but if we assume that that we are moving a particular charge, that test charge, we are moving it from a far distance from infinity to a particular point, it simply means that our work done would simply be equal to potential energy, because potential energy at infinity is always 0. So work done in that case will no longer be equal to change in potential energy, but work done will just be equal to what? Potential energy, right? Now we have two cases. You are bringing charge Q3 from infinity to this point. So it means you are going to do work against this charge Q1. So that's the first potential energy. So our network, or our total work, is going to be the potential energy against this, so which I'm going to call U13. So in bringing it against this charge, then the second is going to be the work done against this charge Q2, so which is going to be U23. So when you get this and add them up, it gives you the work done against these two charges. Remember that potential energy or work done is a scalar quantity. So you do a direct addition. You don't consider vector addition in this case. So I'm going to rub this. So I'll have space. So what do we want to do here? What we want to do is to be able to get this, and then we are done with the first part of the question, right? Now, if you recall, U is simply K times Q naught divided by R. So this is the formula for U. So to do this, we simply have our work done, our network, which is what I will call it, is going to be, considering this first one, 1 and 3, is going to be K 9 times 10 to the power 9. Then our charge 1, it has a value of minus 2 times 10 to the power minus 6, right? Then our charge 3 has a value of 2 times 10 to the power minus 6, right? Divided by the distance, this distance from 3 to 1, because this is 0, so the distance is 6, from here to here is 6. So that is the distance, plus this second part, which is 2 and 3, between this and this. So it's going to be 9 times 10 to the power 9 times 2, charge 2 is positive, 2 times 10 to the power minus 6, charge 3 is also positive. 2 times 10 to the power minus 6, right? And what is the distance between these two? 6 minus 3 will give you 3. So the distance is 3 meters. So I want to punch this and then add them up. That becomes my work done. So I have, so your 9 times 4 is 36. 36 divided by 6 is 6. So for the first one, I have 6 times 10 to the power 9 minus 12 is minus 3. Right? Okay. This is minus 6. So this is this. Then I have, for this one, this is also 9 times 4 is 36 divided by 3 is 18 and 12. So this is going to be plus 12 times 10 to the power minus 3. So if I add this up, 12 minus 6 is going to give me 6 times 10 to the power minus 3. And the unit is joule. So our net work or our total work is 6 times 10 to the power minus 3. So I believe this one is very clear. Now the second part of the question says we should calculate the total potential energy of the 3 charges, of the system of 3 charges. So that is to say, we're just trying to find the total potential energy that will be within the system. The way they are now, what will be the total potential energy within the system? So the total potential energy, if you still remember, potential energy is a scalar quantity. So the total potential energy is going to be potential energy between 1 and 2 plus potential energy between 1 and 3 plus potential energy between 2 and 3. So this is going to be the total potential energy of the 3 charge system, right? Now let's solve. I'm going to do it one after the other. So U12 is going to be KQ1 Q2 divided by R12, right? So I will have 9 times 10 to the power 9 Q1 minus 2 times 10 to the power minus 6 Q2 2 times 10 to the power minus 6, right? Divided by R12, the distance between 1 and 2 is 3. So I have 3. Quickly I'll punch this. So 4. Okay. This is 36 by 3, 12. So I have minus 12. Minus 12 times 10 to the power minus 3 joule, right? Now I've gotten U12. The next thing I want to do is to get U. So let me write it here. U12 is minus 12 times 10 to the power minus 3 joule. So let me rub this. The next thing I'll be finding is U13, U1 and 3. So which is going to still give 9 times 10 to the power 9. Q1 is minus 2 times 10 to the power minus 6. Q3 now is 2 times 10 to the power minus 6 divided by the distance R13. The distance between 1 and 3 is 6. So I have 6, right? And this is 36 again, divided by this is 6. So I have minus 6 times 10 to the power minus 3 joule. So I'll put that value here. So U13 is minus 6 times 10 to the power minus 3 joule. Then let me rub again. So the last I want to get now is my U23. U23 is 2 and 3. So I have 9 times 10 to the power 9. 2 is what? 2 times 10 to the power minus 6. 3 is 2 times 10 to the power minus 6 divided by the distance 2 and 3. Between 2 and 3, the distance is 3. 6 minus 3, distance is 3. So I have 3. So if I punch this again, this is 36 divided by 3 is 12. So I have 12 times 10 to the power minus 3 joule. So I've gotten my 3 potential energy. So U23 is 12 times 10 to the power minus 3 joule. Remember, our total potential energy of the system, U total, is going to be the addition of these three things according to this formula. We're going to add these three values. Looking at them, this and this are opposite, so this would go. Then our final answer will just remain minus 6